to discuss the Maclaurin and Taylor series and the power series. If you have recalled in the previous discussion that we had, that the nth Taylor polynomial p sub n of x at x equals x sub 0 for a function f was defined so its value and the values of its first n derivatives match those of f at x sub 0. So this being the case, it is reasonable to expect that for values of x near x sub 0, the values of the p sub n of x will become better and better approximation of the function x as n increases and may possibly converge to the function of x as n approaches to positive infinity. So we will explore this idea in this discussion. So if you can still also remember in the previous discussion that we had, we already defined the nth Maclaurin polynomial for a function f and the nth Taylor polynomial for function f, a function about x equals x sub 0. Uh, it is not a big step to extend the notion of Maclaurin and Taylor polynomials to series by not stopping the summation index at n. Thus, we are going to have this definition. So, if the function has derivatives of all orders at x sub 0, then we call the series the summation of the kth derivative of f of x sub 0, okay, over k factorial from 0 k factorial times the quantity x minus x sub 0 raised to k from 0 to infinity equals, okay, the function of x sub 0 plus the first derivative of x sub 0 times x minus x sub 0 plus the second derivative of x sub 0 over 2 factorial times the quantity x minus x sub 0 squared plus so on plus the kth derivative of x sub 0 over k factorial times the quantity x minus x sub 0 raised to k plus so on. Okay, so this is the Taylor series of for f about x equals x sub 0. In the special case where x sub 0 equals 0, this series becomes the summation of the uh, kth derivative of f of 0 over k factorial times the quantity x minus x sub 0 raised to k from 0 to infinity equals the f of 0 plus the derivative of first derivative of 0 x plus the second derivative of 0 over 2 factorial x squared plus so on plus the kth derivative of 0 over k factorial times x raised to k plus so on, which in which case we call it as Maclaurin series for f. Note that the nth Maclaurin and Taylor polynomials are the nth partial sums for the corresponding Maclaurin and Taylor series. Okay, so let's have example number 1. Find the Maclaurin series for e raised to x. Okay, so in this case, okay, we already have discussed we already this is actually an example in the previous discussion that we had, the nth Maclaurin polynomial for e raised to x. Okay, so from the previous discussion that we had, we know that this would be p sub n times of x. This is equal to the summation of uh, x raised to k over k factorial, okay, from 0 to infinity, which is equal to 1 plus x plus x squared over 2 factorial plus so on plus x raised to n over n factorial. Thus, in this case, since we are just going to extend this one, then we have these Maclaurin series for e raised to x as you have the summation of x raised to k over k factorial, okay, from 0 to infinity, which is equal to 1 plus x squared over 2 factorial plus so on plus x raised to k over k factorial plus so on. So this is the Maclaurin series for e raised to x. So another, find the Maclaurin series for sine x. So again, this is an example of the previous discussion that we had, okay, from the Maclaurin polynomials for sine x. Okay, we have, okay, the p sub 2k plus 1, okay, of x is equal to p sub 2k plus 2 of x is equal to x minus x cubed over 3 factorial plus x to the fifth over 5 factorial plus x raised to 7 over 7 factorial plus so on, plus you have the quantity negative 1 raised to k, okay, times x raised to 2 plus 1 over the quantity 2k plus 1 factorial, where our k is equal to 0, 1, 2, and so on. Okay, so in other words, the Maclaurin series for sine x would be the summation of the quantity negative 1 raised to k times you have x raised to 2k plus 1 over the quantity 2k plus 1 factorial from 0 to infinity, okay, is equal to x minus x cubed over 3 factorial plus x to the fifth over 5 factorial plus so on, plus the quantity negative 1 raised to k times 2 raised to k plus 1 over the quantity 2k plus 1 factorial plus so on. Okay, so let's have another example. You have find the Maclaurin series for cosine x. So again, this is an example of what we had in the previous discussion. Okay, and we found out that the Maclaurin polynomial for cosine x would be, you have the p sub 2k times x, that is equal to p sub 2k plus 1 of x is equal to x minus, it's not x, it must be 1. Let's try to delete that one. So this is 1 minus 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus, you have x raised to 6 over 6 factorial plus so on, plus the quantity negative 1 raised to k, okay, times x raised to 2k over 2k factorial, where k is equal to 0, 1, 2, and so on. Okay, so in other words, since this is the Maclaurin polynomials, then our Maclaurin series for cosine x would be you have the summation of -1 raised to k times x raised to 2k over the quantity 2k factorial from 0 to infinity, which is equal to 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x raised to 6 over 6 factorial plus so on, plus the quantity -1 raised to k times k raised to 2x over 2k quantity factorial plus so on. Okay, so we have this answer. Another example, find the Maclaurin series for 1 over 1 minus x. So in this case, again, this is another example of Taylor and Taylor polynomials from the previous discussion. So in this case, the okay, let me correct. This is not Taylor, but this is Maclaurin series. Okay, so the Maclaurin series for this case is you have the p sub n of x is equal to the summation of x raised to k from 0 to infinity is equal to 1 plus x squared plus so on plus x raised to n, where n is equal to 0, 1, 2, and so on. Okay, so in other words, the Maclaurin series would be, the Maclaurin series for 1 over x minus 1 would be the summation of x raised to k from 0 to infinity, which is equal to 1 plus x squared plus so on plus x raised to k plus so on. So let's have a second example. Find the Taylor series for 1 over x about x equals 1. Okay, so in this case, this is an example of the previous discussion, okay, that the Taylor polynomial for 1 over x about x equals 1 would be, you have the summation of the quantity -1 raised to k times x minus 1 raised to k from 0 to infinity, which is equal to 1 minus the quantity x minus 1 plus you have x minus 1 quantity squared minus the quantity minus x minus 1 cube plus so on plus -1 times 2 raised to k times x minus 1 raised to n. Thus, the Taylor series for 1 over x is about x equals 1 would be, you have the series, the summation of the quantity -1 raised to k times x minus 1 raised to k from 0 to infinity would be equal to 1 minus the quantity x minus 1 plus x minus 1 raised to 2 minus the cube quantity of 1 plus so on plus the quantity negative 1 raised to k times x minus 1 raised to 4. Okay, so that is the Taylor series. Let's have the power series in X. So the Maclaurin and Taylor series differ from the series that we have considered, okay, that their terms, okay, are not merely constant but instead involves a variable. These are when you have these, you have the power series. So if we are going to define the power series, you have, if c sub 0, c sub 1, c sub 2, so on, are constant in the variable of x, then a series is in the form of the series of the form of the summation of the c sub k times x raised to k from 0 to infinity is equal to c sub 0 plus c sub 1x plus c sub 2x raised to 2 plus so on plus c sub k raised to x plus so on, which is called the power series. So some examples of these power series would be the summation of x raised to k from 0 to infinity, which is equal to 1 plus x squared plus x cubed plus so on. Another example would be the summation of x raised to k over k factorial, okay, where k is equals to 0 to infinity, is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus so on. And another example that we can help is the summation of negative 1 raised to k from 0 to infinity, okay, times the uh, x raised to 2k over 2k factorial, which is equal to 1 minus x squared 2 factorial plus 4 raised to x over 4 factorial plus 6 over 6k uh, plus so on. Okay, so let's have this one.